Hello and welcome back to another session. In today's session, we'll learn about one of the application integration services in AWS, SQS, Simple Queues Service. This is the first service that AWS launched in 2004 and helps in integration of various applications. Let's get started. We are going to cover the fundamentals of SQS, followed by its key features. We will also learn about the two types of SQS queues and some of the key functionality supported by SQS. Finally, we'll take a look at the pricing model of it. AWS SQS is a fully managed message queuing service which eliminates the need for developers to manage the middleware associated with messages. Instead, AWS does it for us. It is a regional service which lets you to integrate AWS compute and database services within a single region. SQS mainly helps in decoupling the microservice, distributed systems, and serverless applications, and also scales seamlessly. It lets you send, store, and receive messages at any volume without losing any messages or requiring other services to be available all the time. You can use SQS along with other AWS services to integrate them and pass messages between them. For example, you can set up an SQS as a trigger for a Lambda and post messages to the SQS, which will trigger the corresponding Lambda function. Moving on to some of the key features of SQS, AWS manages all ongoing operations and underlying infrastructure needed to provide a highly available and scalable message queuing service, which eliminates the administrative overhead. SQS lets you transmit any volume of messages reliably. Multiple copies of every message are stored redundantly across multiple availability zones so that they are available whenever needed. You can use SQS to exchange sensitive data between applications using server-side encryption to encrypt each message body. You can store the keys in KMS. SQS scales elastically with your application, so you don't have to worry about the capacity planning and pre-provisioning. There is no limit on the number of messages per queue. Decouple sending and receiving components, which eliminates the need for both the components to be up and running all the time. The receiving component has to poll SQS for updates periodically. So these are the key features around SQS. There are two types of SQS queues, standard and FIFO, and they mainly differ based on how they treat the incoming messages. And you can choose one based on your application requirements. Notice that you can't change the queue type after you create a queue. Standard queues support a nearly unlimited number of transactions per second, whereas FIFO queues supports up to 300 messages per second by default. And when you send 10 messages per operations in batch, it supports up to 3000 messages per second. However, this can be increased by raising a support ticket with AWS. Standard ensures messages is delivered at least once, but at times more than one copy of a message is delivered. However, FIFO ensures messages is delivered exactly once, so results in no duplicates. Standard offers best effort ordering, meaning the messages can be delivered in a slightly different order than how they are sent. But with FIFO, it's always a strict first in and first out order. These are the main differences between the two types of the queues. Next, let's see some of the key functionalities supported by SQS. You can send message payloads up to 256 KB of text in any format. Each 64 KB chunk of the payload is billed as one request. You can send, receive, or delete messages in batches of up to 10 messages or 256 KB at a time. Batches cost the same as a single message, making it more cost effective. SQS retains messages in the queue for up to 14 days. It can be anywhere between 1 minute to 14 days, with 4 days being set as a default value. Long polling helps in reducing the number of times your queue is being polled for messages, thereby reducing the cost. When your queue is empty, Long polling requests wait up to 20 seconds for the next message to arrive. Also, this costs the same amount as regular requests. This is also called as receive message wait time. When a message is received, it becomes locked while being processed. This keeps other computers from processing the message simultaneously. If the message processing fails, the lock will expire and the messages will be available again. This can also be controlled by setting visibility timeout. It is a period of time during which SQS prevents other consuming components from receiving and processing a message. This is called as message locking and it is very helpful. Dead letter queue helps in processing the messages which are not processed successfully by a receiver or consumer. It receives messages after a maximum number of processing attempts cannot be completed. As with most AWS services, you pay only for what you use and there is no minimum fee for using AWS SQS. First 1 million requests are free for every month and after that million requests, you pay 40 cents per request in case of standard queues and 50 cents per request for FIFO queues. Every API action counts as a request, so it's pretty straightforward. We are at the end of the session. Let's have a quick look at the major highlights of SQS. It's a fully managed queuing service which decouples and scales microservices, distributed systems, and serverless applications seamlessly. It ensures to deliver your message at least once, and the messages can be easily encrypted and dynamically scaled to meet your needs. It comes in two varieties, standard and FIFO. You can select one based on your application requirements, and you pay only for what you use. That's it for today, guys. Hope you found it useful. If you have any questions, please leave them in the comments below. We'll see you soon in next session. Thank you.